Hello, friends. Gonna get started with a little discrete structure. So let me go ahead and share my screen, and it'll be screen 4. All right. So let's see how Canvas is doing today. We've had an exciting week here on campus. Rough memory, it's been more than a week since I've seen any of my students face to face. I think they all are doing well from what I've got reported so far. Um, so looking at this week, um, coming up on Monday, the 22nd, we're going to have homework 5 to go over. And then on Tuesday, we're going to have an exam over chapter 5. So I like the exams more. Okay, so compare the number of operations and the time needed to compute Fibonacci numbers recursively and iteratively. You know what? That sounds like a lot of fun. I have to admit, I have a soft spot in my heart for Fibonacci numbers. So let's go ahead and see if we can take a look at that. So this is going to be exam 4 over chapter 5. So we'll make a new class for this inside our discrete structures workspace. So anyway, I just I don't know why. I think it's because I understand the Fibonacci sequence. All right, so let's make a new package, and I'll call this exam 4 over CH5. Okay. And I'm going to make a new class, and I'm going to call this compare Fibonacci. Public static void main. And first thing I always like to do is just make sure that this is going to work. Yay! Okay, so that's a cool start. All right, so let's pop back in here. Let's okay, iteratively versus recursively. Okay, so we're going to have a I think the way that I'd like to do this is have an operations counter. So I'm going to have a class, and I'm going to call this operations counter stats equals new. No way that I'm going to type that correctly. Okay. So that class doesn't exist, so we'll create this class right quick. I'm going to do it externally. Oh, don't need that. I apologize. Okay. So we'll do that externally. We'll circle back to that as we need to. Actually, I'll do recursive stats And I will do iterative stats. Okay, so let's do, let's say, int equals, let's start out with like 4. Okay. All right, so I don't really want to go and create a recursive Fibonacci sequence. Like I know we could, but instead I'm just going to do Java recursive Fibonacci. There you go. Tutorials point is usually pretty good. Yeah, and so this is a recursive one, right? Yeah, let's grab this. We'll drop this right here into our main class. And it's going to tell us, hey, that doesn't exist yet. So I'll create a method and it needs to return an int. And let's see. So, oh, it's passing in longs. Okay, so this will be a long. And this will be a long. And then we'll just get rid of these right quick. Okay, so it's passing in, not I. Cool. Okay. Now, so this is the recursive. And so actually we don't need this yet. We'll circle back to that. I'm going to change this just a little bit. I'm going to make this 1, 2. Okay, 0, 1, 1, 3, 2, 0. Okay, let's see if that's enough. 1, 2, 3, 4, 5. Whoops, we'll do one more. 6 and 7. Okay. So let's talk about the number of operations. So this is going to be our recursive stats, right? So I'm going to come in here and I'm going to say, all right. And to get to this point, this will be recursive stats dot increase if. And it says, it probably is going to say, hey, create local variable. All right. Oh, I see. So we need to probably pass our object into this. And it's going to complain, and it's like, hey, it's not quite set up that way, so we'll pass it in, right? Operations counter recursive stats. And now it says this doesn't work. So I'm going to create this method, increase if, and I'm going to say this dot if count plus plus. Now it's going to say, hey, that doesn't exist. So I'm going to say, hey, go ahead and create a field int if count. And okay, so this is lazy programming. The default if count should be 0. And all right. Why is it saying this is now a problem? Oh, I see. It's because we actually have changed this just a little bit, right? And so oh, and now we have to pass in for all of these that same object. Right? And so, okay, so now that's all happy. And we're passing in the object, right? 1, 1, 2, 3, 5, 8, 30. Yeah, see, now those, oh, I guess I should change this. That print's a little nicer. Okay. Now, if n is equal to 0, and it is, then return n. Okay. All right. So that should be one if to get to here. So we'll come in here and I'll just do this. I'm going to wrap this just a little bit. And then come here and we'll do plus. Recursive stats dot get if count. Okay, so get if count doesn't exist. So we're going to just come in here. It should return an int, and you should return this dot if count. Save that and let's run it. Yeah, we'll save those as well. That's okay. All right, now we need to go change this just a little bit. Okay, so now we can see that this is slightly different. So I'm going to modify all of these. And it looks like I can get away with just, let's try that, see if that works. Okay, so this is interesting. So if it is 0, then it just returns n. All right, if n is 1, so if n is equal to 1, which that is, it pops in here and it says return n. You know what we're not doing? Every time we call this, we need to come back and we need to say, all right, so after we do that one, we need to do reset the if count. Okay, so that doesn't exist yet. So I'm going to create it. And all we're going to do here is we're going to just say this dot if count equals 0, right? And so the idea is we need to reset this every time. The reason why I knew that, how I knew that, when you look at this right here and this pops up as a 2, if you think about the code, if n equals 1, which it does, then we have done one if check, technically 2, right? But we'll just count that as one if operation. And so it's checking these 2 conditions. We're just going to count that as one operation, and then it should pop back 1. Well, how many if statements does it have to go to if n equals 1? It has to go through 1. So these 2 should give the same answer. But it's not doing that, and that's how I know that I need to have this little nugget here. So I am going to boldly just bop that in. And so the idea is now before every call, we're resetting it. So let's run that again. And see, this is what I would have expected to see. All right, so 1, 1, 2, 3. Now this is interesting, right? It takes one pop to get to, so let's say that this is 1. So if it's 1, then it does increments the if once, and then it pops it up. Now, if it's 2, check this action out. It comes up and it says, okay, 2. Is it 2? No, it's not 2. So what do we need to return? Well, we're going to return whatever we find if we call this once and we call this twice. So for 2, it pops in, here's the first one, and then this is where we're going to get the second one, and then this is where we're going to get the third one. And so that explains why when it's 2, we get 3 if comparisons. Cool. All right. So operation here, we need to do, first of all, we probably need to do this. I'm going to say this. I'm going to say recursive stats dot increase so we've got 2 subtractions and an addition. So I'm going to call this 3 because 1 subtraction, 2 subtractions, and then an addition. Okay. Notice how we're not doing any up here. So we're just doing it right here. So I'm going to create this method. And then this is going to be number of operations. And we'll come back here and we'll just say this dot and this doesn't exist yet, so we'll create it. And this is lazy programming because I know it defaults to 0, and we'll worry about resetting it to 0 here in a little bit. Okay, so now we need to come back up here and we need to do something like, okay, so that's our ifs. So let's go ahead and stretch this out just a little bit more. And I'm going to say, so let's get our plus signs. That way you know. Okay, so now it's going to be plus. And I'll do okay, so this doesn't exist. So we will just create it. And it's going to return an int. And I need you to return. I'm not sure of my spelling. If you're wondering why I'm being weird about this, it's because I'm not sure of the spelling. So it's going to be this dot. Cool. All right. So let's see if we can run that. On the first one, it should have been 0. And we see that is the case. And this is ugly, by the way. At least I think it's a little bit ugly. Okay, so now that's what it takes to finish the first one. Okay, now let's get the second one lined up. And so we'll do I'm getting lazy, not paying close attention. This is how mistakes get made, by the way. I don't know if you realize that or not, but that's my personal opinion. That's nice. And the funny thing is, I know that I'm probably going to delete this later, but for now, this is kind of interesting to me. And so let's just space these out a little bit. All right. I lost my pattern there temporarily. There we go. Okay, so let's see how that looks when we run that now. All right. These numbers still make sense. These numbers now make sense a little bit more. And now add or subtract, we do, okay, those numbers make sense. 0 on the first try. Okay, let's say it's 2. So here we have 2 bops down here to this. And so we have to do 1 subtraction, 1 subtraction, 1 addition. And so that's how we get to the 3. We pop back in here for n minus 1. and n minus 2 to get our second and our third comparisons. So 3 comparisons, no, 2, 1. How does this get to be 2? So if it's 2, n minus 1, so 1 to get in, and it's going to miss and come down here, then shouldn't that be 3? Because we have to calculate n minus 1. So 2 minus 1 is going to be 1, which will return 1. Oh, and as soon as it hits a 1, but shouldn't it also have to do this one? That's interesting. Okay. All right. So the third Fibonacci, so 3, Oh, it looks like I messed this up. Let's fix this. And let's just stay consistent. All right, so I'm not 100% sure, but I feel pretty good, like we're doing the majority of the accounting that we need to do. Okay. And so now let's go ahead and let's do 100. So, right. Not sure if this will blow up or not. We're going to try it. Okay, so it's still grinding. Maybe I should have dropped the 50th. Okay, but now this is encouraging, right? This is what we wanted to see. So now we're going to come in here and I'm going to say plus seconds. I'm going to call this okay, so get time doesn't exist. So we're going to create a method for it. And this is going to return a long. And we don't have this set up yet. So I've got a couple more things that I need to go to do. So here's how I'm going to do this. I'm going to say start timer. And so it's going to say, hey, that doesn't exist. So I'm going to create, I'm going to say this dot, oops, start time equals yeah. And so it's going to say, hey, that doesn't exist. So I'll create it. By the way, good code hygiene right there. And now I'm going to save that. I'm going to come back here. I'm going to say, we're going to grab this. I'm going to end that there. I'm going to say stop timer. Now stop timer, hey, stop timer doesn't exist. I don't know if anybody noticed this, but it hasn't stopped running yet on 100. So we're just going to grab this code, paste it in here, modify just a little bit. OP, that doesn't exist. So I'm going to create it. And now I'm going to say this dot stop time minus this dot start time. Now, because I'm paranoid, I have no faith in my ability to do stuff, we're going to run it like that. Now, what I'm going to point out is this seems to not be working. So let's do 20th, right? 20th. Stop you. No idea how far it made it for sure. Well, for all I know, that's correct. Let's do 30th. Okay. All right. So let's keep a little bit of data as we're going. So I'm going to do 20th here. 30th. Let's do 40th. And let's pop out and do the 50th. Okay, so let's read what that is essentially saying. It's saying start our timer and then do this big print. And inside this print is the call for the recursive. And then at the bottom of that, we stop the timer. And then we print off the time. And then we reset the count. Okay, notice how there's a factor of 7 between 20 and 30, and then a factor of 100 between 30 and 40. And so I'm going to let this grind for just a little bit, and we're going to go and we're going to now look at an iterative, because an iterative might be significantly faster, it might be significantly slower, might require a whole lot more operations. I don't really know, but what we are going to find out is we're going to find some code and we're going to keep track of it, and we're going to see how the number of operations compare. Okay. So let's bring on here, and I'm going to do Java iterative Fibonacci. And it looks like some other people have tried this before, a few other options. So so here's the recursive. And yeah, they get stuff that they like. And here's the iterative. Can we copy this? We can copy this. All right. So now we need to come in here. Oh, hey, 50th got done. So I think that took 1.5 minutes. I don't have any data to back that up, but that's what we're going to go. Okay, so now, before we do too far, let's just paste that code in. AIS. Okay, so let's do this. Let's say let's just come up here and let's start slow, and we're going to taper off. Actually, this is the one that has all the bells and whistles with it. And so I will start that here. Now, I don't want recursive stats. Now I want to switch it over to iterative stats. By the way, it is not lost on me how ugly this code is right now. If you find yourself doing copy pastes, you're wrong. Okay. I'm going to add iterative. And so this needs to be iterative stats, get ifs, get adds, stop timer, get time, reset if count. You know what we didn't do? Ha 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 ha. That might be why our ad count is going up in weird ways that it didn't occur to me. We probably need to come in here and we probably need to do you don't exist. So wait, go create you. And we just do this dot arithmetic count equals 0. Yay. Hey, you know what? I've got some space in here that's just waste. So I'm going to tidy this up just a pinch. Oh, that's a insulting space. There's another space. Oops, wrong button. That's a little cleaner. All right, so we've got the we've got this line of code now. So we need to come in here. Not sure what made me think of that. You know, sometimes my brain, I don't understand it, it doesn't understand me. And that's okay. Ugly. By the way, if you ever have to do this much copying and pasting, this is ugly code. This is what I would call quick and dirty. Not very effective, not very efficient, but you know what? It's going to work. Now, let's see if we can have any more insight. So that's going to get old in a hurry doing it to 50. So I'm just going to pop in here and comment this little block of code out right quick. There you go. So that won't take quite as long. I'll go ahead and stop this, run it again, blip, and it's done. Okay, so now we need a different function call. And we probably need to do. Here we go. Now, it complains because it doesn't have this. So we'll do this, like this. I'm going to change you, by the way, to long. Okay, because it's long down here. Same number types. Okay, previous number equals 0, current number equals 1. All right. So now what we need to do is we need to do iterative stats. And we need to do dot what do we call it? Increase. So now it complains because, oops. There you go. Now, this does not exist. So we're going to create it. Oh, yeah, I made a mistake. We're not quite ready to create it yet. To get through the next line of code, okay, just so that we're all clear. To get through that line of code, it has to do 1, 2, 3 assignments. And listen, is that a big deal? I don't know, but it's an operation, right? And so whenever we have an operation, I want to keep track of it. That's what we're supposed to do. Okay, so in order to get here, we have to do a comparison. So I'm going to give them as a freebie the, no, I'm not. I'm going to say increase assignment operator by 1, because every time they get to this spot, they've assigned a new value to 1. I'm also going to say dot increase if. It's this one, because inside this, okay, so that means we need to, before this starts, actually, you know what? I say we do resetting both of these. Okay, so reset count, if count, and add count. That's good. We start the timer, stop the timer, we get time. Okay, I'm okay with all of this right now. All right, the reason why I increase the if, because this is a comparison if I is less than the nth number. So we have to keep track of that. Now we have to grab this. To get to here, we're doing 1, 2, 3 assignments. And then we're also doing increase arithmetic by 1 because we're doing one addition. Okay. And then we just do a return at the end of that. Okay, so I'm okay with all of this, but I do need to add one more eensy weensy teensy detail. Trying to decide where I'm going to do it. I think I'll do it right here. Get now that does not exist, so let's create it. Pop in here. Need to return an int. You are hateful. That's how I feel about that. And it's going to be this dot assignment count. Yep, saving it sounds great. Go for it, buddy. Assignment count is 3. Let's go see if we believe that. Okay, so we're passing in the nth number, and we come in here and we assign 3. If, okay, I is equal to 1. If I is less than that, oh, you know what? I'm going to take this one and I'm going to grab it and I'm going to drag it right there, because you actually have to do one if just to get into the for loop. So that's a guaranteed if there. And then every other time, once you're running it, okay. No, I think that's gonna, I think, okay. So for the first one, it makes sense that it's wrong. In the second one, it'll be correct because you'll have to do one to get in and then one more. No, I'm gonna stay with it here. I really think it's going to be a change of one. And, you know, I would be really missed as a computer science instructor if you didn't know the horrible joke that comes next. 2 hardest things in being in programming: 1, typos; 2, good variable names; 3, off by 1 errors. Okay, let's run that puppy. Oops, it's not happy about something. Danger, Will Robinson. Why? Don't do that. That seems wrong. What are you complaining about? Oh, I see. Okay. Okay. 0th Fibonacci is 1. Ifs to get there is 1. I agree with that. Add or subtracts is 0 because we didn't have any. Assignment operators 3 because just to get that algorithm started, they're loading 3. Took 0 amount of time. Okay, so let's do some horribleness. Let's be less horrible. For int fibnum equals 0, fibnum less than 8, fibnum plus plus. Come in, drop you. We're going to drop you there. Fibnum, come with me. Fibnum. All right. I don't know if y'all notice a trend or not. By 8, oh, we didn't have times. Well, that's not really useful. All right, 0, 1, 1, 2, 3, 5, 8, 13. 0, 1, 1, 2, 3, 5, 8, 13. Cool. Okay, let me do one more adjustment. All right, copy this. Okay, so now let's do recursive, 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 recursive. Recursive. Whoops. Okay, and now this needs to be just good old fib. Okay. So I'm going to do this in all one fail swoopiness. Okay, save that, run that. Okay, nice little repetition here. Ifs are add or subtracts. Okay, this is actually going up a little bit slower. And our times are staying about the same. But the thing I want to point out is this is still just not that interesting. Okay. So now what I want to do, I'm going to grab this and I'm going to say, let's start at 10. And I'm going to say less than 40 and plus equals 5. Yeah. So pop down here just a little bit and grab this. And I think I had starting at 10, 40, and plus equals 5. Okay. Getting a little long on the print statements. So I'm going to change this to I fib. Oh. And I'm going to change this to okay. So now I need to just kind of do a little copy pasting. Okay, see if I can follow some similar pattern up here. All of you horrible people are now gone. I only want stuff that's inside my loop. Yes, we know that's useless. Wrong button. Okay. So this one we will just make an R. And this is just to make it look pretty. Okay, so let's see. Are we actually learning anything? 0, 1, 1, 2, 3, 5. Oh, this one I think is giving us a wrong number. Well, that's interesting. It's supposed to be 0, 1, 1, 2, 3, 5, 8, 13, 55, 6, 10, 6, 75, 6, 7, 6, 5, 7, 5, 0, 2, 5. Okay, so the first number is coming back wrong. Let's go down and look at our. Oh, I see. Current number equals 1. Previous number equals 0. So that is actually a problem, but I'm okay with that. And I think they never intended this to actually get called for that. So I'm going to be okay with that. Okay, I feel like we're not learning a whole lot of interesting stuff here. So I'm just going to blow this off for now. And it was copy pasted anyway. I'm going to blow this one off as well. Now, we know that this gets interesting right around 50. So I'm going to make this one go right around 50. And let's just see what happens there. I think 50 took like a minute and a half. So I suppose what we need to do is we need to come up with a sum total of operations. Yeah, this last one takes about a minute and a half. All right, so while it's working on that, I'm going to come up with a I'm gonna do a different print. I'm gonna do this out. Fib, and this will be plus fib num. Oops, plus is plus. Oh, it doesn't actually give it. Oh, darn. So we're actually getting a rollover there. Well, that is interesting. Okay. But notice how the time is always 0. Is that really the case? Did we do anything wrong? Start timer, stop timer. Yeah, and also it just blows through them, like it gets there quicker. So how much quicker? Hard to say, but this is when the weird rollover thing happens. And so that's when probably we need to be saying, We need to do some rollover detection or something like that. Wow. Well, that's frustrating. But what this shows is the iterative approach definitely is doing fewer operations, fewer comparisons, and a lot more assignments. And it does that a lot quicker. So it's using assignments instead of if statements. It's doing a lot more if statements. And again, that shouldn't be a negative number. We had rollover happen there. Well, friends, that's my interpretation. I'm going to go ahead and add this to get staging, get it all. Yep, there's everything we need. I'm going to say, all right. So, oops. Yes, add that. Do you know what you want to be? No, you don't know what you want to be. Okay, so we'll print that. Okay, friends, that's pushed up to the cloud. If you have any questions, comments, or concerns, let me know. Not my greatest code, but I think it's going to work. So anyway, have fun with that. Good luck with that. Let me know if you get any other ideas or other things. We could change some of the process. I think one of the differences is here, we're using an integer. We're not using a long. And I think that's causing us to have some rollover problems. Down here, we're using in as a long. So we're never using an integer. And that helps us avoid that. And the other place that we had rollover, so that explains why this one rolled over and this one did not. Here where we're having rollover, one way to fix that would be to go into our code here and change these ints, especially for the if count, obviously, to a long, and then that would probably fix that problem. All right, friends, thank you all for your time. Oops, did I make a mistake? Oh, this was the one where we're going to do total count. So I'm not ready to do that yet. I'm just going to delete that for now, save it. Anyway, that's what I have. I hope you have some fun with it. Obviously, there are some improvements that could be made to my code, but it is enough to get you started. Thank you all for your time. Have a wonderful day, and please let me know if I can do anything to help. Take care, friends.